Nice. I say we go. Hey, there you go. Close. That's sine 2a. Right? Cosine 2a? No, it's cosecant squared. Cosine squared. Okay? Now, if you didn't get 8 out of 8, that's okay. But it might bring your attention that maybe you need to practice those just by looking at your note card and writing things down. Oh, I don't want to learn. I don't want to work in it. But you got to. That's important. Yeah.
Cosine 2a, the one that has 3 different roots.
It is. Cosine 2a can be written as cosine squared minus sine squared. 1 minus 2 sine squared. 2 cosine squared minus 1. Okay? You need to know those. We're going to do them again. Maybe we'll do them for points. What do you think of that? Yeah, I think that would be fun.
Are we doing them right now again? Or?
No, tomorrow. So if you didn't get any of them right, hopefully tomorrow you get one right. You have a chance to look over them tonight. Okay? Extrema of functions. There's an old saying in calculus, if you want the material to get harder, just turn the page. There's a lot of pages to turn, I think. Extrema. You did it last year because we just did the topic in pre-calc today about how to find the vertex of the maximum and the minimum of functions. Although this isn't going to be as easy because there you just use the calculator to find it. Okay? What's that? Sign-out sheet? Oh, field trip. Love them. Extrema of functions. Maximum, minimums. What do you know about the maximum of a function? That's for the vertex of a quadratic. What's true at a maximum? The highest point and the slope of the tangent line is 0. The slope of the normal line is undefined. So that means f prime of x equals 0. Did you jot that down? F prime of x equals 0 gives you the x coordinates of maximums and minimums. How do you write that down? Easy. You take a pen. You say f prime of x equals 0. X coordinates of max and min. It wasn't that hard. See how it works? That means if you have a graph that goes the derivative is going to equal 0 at those points. That's where the derivative equals 0. Well, you find the y coordinate by putting it back into the function. Remember, f of x equals y. F prime of x equals the derivative, or velocity, or maximum, minimum, things like that. So if you have the x coordinate for this, if you have the x coordinate, you can find the y coordinate by putting it back into the function. Oh, but couldn't you have a max or minimum at a cusp? You could. It is the highest point. That's true where the derivative is what? Yeah, somebody just said it. Undefined. So f prime of x equals 0 or undefined tells you where you can have maximums or minimums. Yeah, the derivative equals 0 or undefined. Well, yeah, I don't know. It's slack. I'm just winging this. Or undefined. That's over an open interval. See how I kept drawing? What if you're at a closed interval? What would be the maximum or minimum? The dots. And coincidentally, the dots. Oh, there you go. Got two of you. Coincidentally, the dots would be what? No. They'd be at the end points. End points. So in a closed interval, you can have a maximum or a minimum at 3 places. The beginning, the end or any place where the derivative is undefined or the derivative is 0. Nice.
That's for if it's,
On a closed interval. On an open interval, do you have any endpoints? No. So it can only happen if it's undefined or 0. Maximums or minimums. So if you have a closed set, it can be f of a, f of b, or the derivative. On an open interval, it's just the derivative. Those are the extrema functions. You got no pictures. I got pictures.
you gotta fix your 1.1.
Yeah, you have to organize it. To me, that's organized. I mean, that's how it is. Ding. It's organized. Okay?
That's organized too.
It is. I can roll with that, and I feel just fine. Ready?
Yeah.
Oh, I don't want to reinstall that. I want to. Oh, there we go. So, this is a little different definition than you're used to. Usually, when you say increasing function, you say going up from left to right. This is a mathematical way of writing it. Ooh, go back. It's a mathematical way of writing it for problems that say show that. Okay? If you run a problem that says show that, you're expected to use these 3 ideas for your answer. How do you show that something's true? Easy. As the x's are getting bigger, the y's are getting bigger. And that's a mathematical way of stating that. As x1 is less than x2, that means y1 is less than y2. No, you'll use that in your algebra. Not too difficult. That also means the difference between the two can be positive or negative. Decreasing is also another show that. Again, as the x's increase, the y's are decreasing. Those are my own words. You have to come up with words like that when you're looking over your identities tonight. I'm not doing that. Sure you are. And 2, when you're looking over these rules. I'm not doing that. Sure you are. For the show that problems. And last, as x's increase, y's stay the same. Okay? Yeah, all those are used for directions that say show that or prove that. Do you remember the f of x minus L less than epsilon if x minus c less than delta? It's kind of like that. Okay? Now take a look. What was our theme of the first slide? What? What? Well, the maximums and the minimums, right? Well, take a look. Mathematically speaking, that f of x is larger than any other y value. For any interval, that's the biggest y value. Can you state that mathematically? Well, sure. We're going to start using these to state it. It has to be at the top, so it has to be bigger than any x on this side or on that side. That's what we're getting to with these maximums and minimums. Oh, close that. Sorry. I'm going to click right here. There we go. So, let f be a function of real numbers s. Let c be a definition 4.2. What the heck is definition 4.2? No, I'm not. I'm going to ask Matthew Heyman to read it. Third time now. Definition 4.2. I do? What does it say? Well, go ahead. Yeah, keep going.
On as if f of x is less than or equal to fc for every x and s.
Yeah, how do you draw it? Well, I knew you were going to say that. That's why I have 2 examples here. How do you draw a maximum? At the top of a graph, a dot. That was cool, wasn't it? Stephanie missed it. She was facing out. Ready, Stephanie? Hold on, we'll draw a dot. There. I don't know how that happened, but that's kind of cool. Anyway, that is the biggest y value, and that satisfies its definition. Where's c at? It's the x value right here. Yeah, here's c. What do you think is true about f prime of c? It equals 0. So f prime of c equals 0. C is a constant. It's an x value. Correct. Now, come on, there you go. This one. Where's the maximum at? That's on a closed interval. We talked about that, didn't we? So on a closed interval, your maximum could be at the top, at the end point, or it could be where the derivative equals 0. The question now is, what happens if you have both? Which one is the biggest y value? The end point or the vertex? In this case, it's the end point. This one is still a point of interest. We call it a local max. Local max. Right there. This one, we call a local min. Is it the absolute lowest point? No. The absolute lowest point is right down there. So in that one little sketch, you got two places where the derivative equals 0. You got two endpoints playing an active role in the maximum and minimum y values of a function. Yes?
Is there a local max on the right?
No, that's just where the derivative equals 0, but it doesn't give us anything. Because remember, to be a maximum, has to be the greatest value in an interval. And this one isn't the biggest value in any interval. It's where the derivative equals 0, but that doesn't have to give you a maximum. Did you write that down as an FYI? What did you say? I said, does f prime of c equal 0? Does that guarantee that c is going to give you a maximum or minimum? No. Right here, here's c. F prime of c equals 0. That's not a maximum or a minimum. It's just one of those things. Known as a plateau point.
Like a local max and
Oh, we use our definition. It has to be bigger than any x value on an interval. As soon as I go to an interval, there's going to be a y value bigger right there. If I go to an interval right here, well, that's it. It's top dog. There's nothing bigger than that. Okay? So this isn't just a one-step memorization problem. This is an application of a big topic. Oh, it's almost November. Woo-woo.
It's like 2.5 months.
Oh, it's not. So
To January?
No. Somebody's a little grumpy. All right, moving on. Minimum. I know. I didn't say anything, Grizz, did I? Didn't. All right. Minimums. What do you think that's going to look like? Yeah, the smallest value in an interval. There we go. Dot. And on a closed interval, the dot down there. Yes.
What if you had that background right there? It's top left.
Top left, yeah.
Yeah. Would you have two minimums?
Yeah, you would, except on this first one, I think it's going to be an interval problem, so it's not going to go. Okay? On here, we'll go with the dots, okay, as a closed interval. So the derivative that equals 0 doesn't have to give you a maximum or minimum. Okay? Also, just because something has endpoints doesn't mean it has to be a maximum or minimum. Is this y value on a constant function bigger than or equal to all the other y values? So we, by definition, we call that a max, don't we? And a min. It follows the definition, doesn't it? F of C is the minimum value if it's greater than or equal to every x value on S. S is the interval. Okay? Sample space, so to speak. That's from statistics. Love sample spaces. Okay? All right. I think we're getting the idea. Questions? Okay. Oh, look at this. Grizz?
You just told us that.
No, I did not.
Is this the problem?
You said 8 already.
It's figure 4.
Ready? C. Do you know how to use the letter C? Do you know how to use the letter C? C stands for a critical number. A is an endpoint. I want you to write. It makes those connections go a little bit quicker in the brain, this topic, by writing.
Should I draw this graph? Because I really don't know.
You want me to listen to say it first?
I want to hear you say it first.
I know.
A is at the endpoint, isn't it? B is at the endpoint of the interval. C is a critical number. What defines a critical number? Easy. Take a look at what's happening at C for this graph. It changes from going up to going down. So at C, it's going up or it's going down. The function is, so that's going to be a local max. Is that the biggest y value there is? No. But here the derivative will equal 0. F prime of C equals 0 because the tangent line is horizontal.
That's a local maximum.
It is. It's a local maximum because it's not the biggest one, but it's the biggest in the area. Kind of like when you have a really good sports team and you like win the conference. You're the best team in that area. Well, then what happens?
And you go to the
Then you go to the, oh, look what happens. But we are the best in our area. Yeah, but then the area got a little bit bigger. Here, the derivative is undefined. That's a big point. C is in the domain of the function. C has to be in the domain, and it has to be undefined in the derivative. So f of C of 3 exists. No, the derivative value is undefined. Big, big point. Okay? Because it goes to a cusp, or a vertical tangent line. This one right here is known as a local minimum. This one right here is known as the absolute minimum. Absolute minimum. The function value of A is less than all the other function values in the interval. Okay? So we got a derivative equaling 0, a derivative equaling 0, a derivative undefined, a derivative undefined, a derivative undefined, oh, and then a constant. So the tangent line is constant right there.
So what's the max?
The max would be right here. That'd be the absolute maximum, the absolute highest. The derivative is undefined. There is a y value right there you can find. This y value would be the function value of C5. Okay? That's the biggest one there is. You're going to be charting your information differently in this section. Nice. You won't ever make a graph like that on your own, but I will ask you to make a graph like this on your test. Yes. Not for homework, just for the test. Yeah, these are fun. Yes. So,
What ends up what would that
So are-
equal?
All I got was a maximum.
what?
Are C3 and C4 local maximums or no?
Yeah, C3 is a local maximum, C4 is a local minimum. Look at that. The worry wart's already worrying about the test. It's not for like 2 months. Yeah.
C3, C4, and C5 are all cusps.
Yeah. C3, C4, and C5 are all cusps. Yeah, the Y values are. It's a point of interest.
What about C6?
C6, that would be, yeah, that'd be a maximum or a minimum. The derivative would equal 0. Okay? The derivative equals 0 for all those values in there. Okay? Don't sell yourself short. You got skills. You can learn this stuff. You should see the people in here last year. All right, moving on. Where does f of x achieve a minimum? From C1 to C4 at C2. Okay? All right.
Is that what like the questions are gonna be like?
Sometimes. Yeah. F is increasing. There's your definition of increasing we had earlier. There's your definition of decreasing, and there's your definition of constants. So we have those, I believe, from your definition that we read out earlier. All right? Okay. Maximum, we got that. We just read it. All right. Do you remember what the brackets mean? The brackets mean including. And 0 to 2 parentheses means not including. So use the graph to estimate the extrema of each interval. So from -2 to 2, -2 goes up to 1, 2, 3, and 2 goes up to 1, 2, and 3. So from -2 to 2, what is the extrema of the graph? Yeah. I'd say it would be an absolute maximum at -2, 3, wouldn't you? And at 2, 3, wouldn't you say that? And there'll be a minimum at -1, -1/4, and 1 and -1/4, right? Does that make sense? Yeah. That's it. Yeah, the whole thing. You just list the points.
Wait, isn't there 2 minutes?
Yeah, there are.
So for each point, you guys the min and the max.
Yeah. Just reading the graph.
What point it is?
What? I got off with this.
Wait, you said
I know, I got off. I went up to 3, so my vision must be off. I should have just went over to here and I must have been standing wrong angle and I went all the way up to here.
Wait, so is that the right answer?
Yeah, I'd probably go with that. If you sat there and probably got your ruler out, you'd probably go up and over to 2.
So the right answer.
Huh?
Why is that the right answer? Why isn't it the right answer?
Because I went at an angle and went up to here. I should have went straight up.
Oh, no, go back.
I can go back, I think.
You did go straight up. It is.
There we go. No, but I said 3 for the Y value, but I must have been off on my, I must have went over too far to went up.
So you just write the min and the max for, like, in between the things they give you.
Right, these are the X values you're working with, and you have to give the points that represent minimum and maximum.
It actually doesn't seem centered on the graph either.
Okay? Well, it is, I got from your book. Best I can do.
Anyways. Oops.
Well, let's try this one. On this one, 0 to 2. So you have an open interval from 0 to an open interval on 2. Okay? Can't include 2. So I have an open interval and an open interval. What is the smallest point? 1, -1/4. And the biggest point? No? If you play the recording back, I said you could have an absolute maximum and minimum on a closed interval. That's an open interval. Therefore, there doesn't have to be a maximum or minimum. In this case, if I drew this picture, there would be neither, because you can't find the highest Y value. You can get close, but you can't find the actual one. So in this case, there would be no maximum. No max. But there would be a min right here.
So why is there no?
Because you can't definitely say what the Y value is. You can only get close to it But since it's not a closed dot, you can't include it.
Only whole numbers or okay, fine.
Or closed dots. Like when I was in kindergarten, 1, 2, 3, third grade, I must have been a real pain. Because my teacher did this on the board, because I was asking so many questions. She goes, how many numbers are between 0 and 1? 1. She goes, no, there's an infinite number of numbers between 0 and 1. Figure it out and let me know when you do. You got to be kidding me. There's an infinite numbers between 0 and 1. Well, yeah, she meant like 1.2, 1.201, 1.2001, 1.2. You get the idea? Oh, no. Yeah. Anyway, so that was third grade. That was my first idea into infinity. Over here, if there's no maximum, that's because you can get close to 2 with 1.9, 1.99, but you can't definitively say exactly what it is, so there's no maximum. Very good. But you can say 1 point without the 9 repeating. Yeah. All right, moving on. So open circle at the endpoint, possibly no extrema. Okay? Open intervals does not give you, just like the derivative equaling 0, does not have to give you a maximum or minimum. Doesn't have to.
Would there be neither on the next one? Oh, no.
There would be one minimum, but no maximum. Okay? Oh, next one. From -1 to 1, there will be a minimum and a maximum. Yes? Because infinity is not a number, it's a concept. There's nothing you can put into the function to generate the number infinity. Infinity implies it goes on without bound. A maximum means it's the top value in a region or an area of a graph. Oh, this one. There'll be a maximum at the vertex and a minimum at the endpoint, won't there? Yeah, I think so. Minimum, maximum. That's pretty good, don't you think? Nice. Oh, FYI. Don't underestimate the power of the TI. If you're going to look at an equation, these intervals are what your domain should be set up to be, because the equations are going to start getting difficult to read. If they ask you to find a maximum over the interval and they tell you to use your calculator, they mean x minimum, x maximum. Set your screen to that window. Don't go from -10 to 10. You'll see a lot of the graph you don't want to see and it'll be hard to figure out what's going on. That's why I'm kind of blocking this graph off. You have to do the same thing with the TI when you get to that point. You'll see me do that a lot in homework questions. -2 to 1. So it looks like there'll be a maximum, but not a minimum. Because there'll be an open circle down here and a closed circle up there. So, and maximum -2 and 2. Extrema of functions. Wait till the applications. You remember all the ones that you found the volume? You know, you can find the maximum volume now with the trough in the water and things like that. Because it was both closed intervals. This one has one open right side and one closed left side. Okay? And also it covered the whole graph, so I had those points and those points twice. Okay? All right. Now, can you write a continuous function with a maximum and a minimum? The extreme value theorem. Love it. Oh, that's an extreme value theorem. If a function f is continuous on a closed interval, then f takes on a minimum value and a maximum value at least once in a and b. So you have to draw a continuous function with a maximum and a minimum on a closed interval. So you have two choices. You can get fancy or you can go vanilla. Makes no difference to me. That means plain. No toppings, no syrup, no fruit, no pecans, just vanilla. I would, here's A,
Wait,
here's B, your closed interval.
that was continuous.
It is. I just labeled the X values.
How was it that?
Closed interval. That means I'm going to have endpoints and not arrows. I'm not going to have arrows, I'm going to have closed dots. If I want to do something very boring, there's a minimum, there's a maximum. Woo, woo, woo. Psh, please.
Oh, I know we just kind of open circle after the, right? The next one?
Continuous with a maximum and no minimum. I will do this, A and B. It says on a closed interval though, maximum and no minimum. Continuous with a maximum and no minimum.
But it's
Can't be outside. One dot. That would not be a function. I have to get from A to B. Aha! The answer is in the theorem. You see how this says, and no minimum? The theorem says if the function is continuous on a closed interval, then it takes on a minimum and a maximum at least once. Therefore, it is not possible. Okay? If you tried this one, that would not be continuous from A to B. So if you had that situation, be leery that there might not be a max or a min. But if it's on a closed interval, rest assured you're going to have it at least once. Right, and not continuous with a maximum, well, it says it has to be continuous, so you can't do that. Okay? Yeah. No, that's not a specific value. Okay?
Going to negative infinity at a
Like right here? I can make one, sure, like that.
yeah, that would have a minimum but no max.
Yeah, but it's not on a closed interval from A to B. It has to have, that means f of A and f of B exist when it's on a closed interval. Okay? A closed parabola? Like that? But that's going to be continuous. The podium? I don't know. I was just playing. All right. I know, but the straight line is a maximum and a minimum. Remember we said the straight line could be both? That's a maximum and a minimum. So that takes that one out. You can't, I couldn't even come up with a picture for it. But some people say, what about this one? Well, that's a maximum and a minimum, so it kind of violates that one. Okay? I couldn't even come up with something because it said continuous. I was just trying to punch holes in the theorem, and you really can't if you follow the theorem exactly. If a function is continuous on a closed interval and has its max or minimum value number c, then what is true? Right. So either the derivative doesn't exist or it equals 0 if it doesn't happen at the endpoints. That number c is known as a critical number. The critical number has to come from the domain of the function. Okay? So, we got that figured out. That can be an open or a closed. This is a closed interval right here. Oops. That's a closed interval. That's an open interval. A closed interval means you have endpoints at the graph with dots. An open interval means you have no endpoints. It could be arrows or open circles. Perfect. I think I got more than 5 minutes worth of stuff to do, but that's okay. You guys have skills. You can read about this on your own. Yes?
What is the bottom?
Bottom part? Oops.
I know. Oh, sorry.
Can I go back? Up, going forward.
Just go back.
Where? Oh, here it is. Found it. Life's good. There we go. Critical number. Good. On this one, this is how you find extrema. That's not how I do it.
So don't write it down.
Yeah, you can, but
And a nice little blue area.
oh, I do it that like I don't think of it like that though. I always do the endpoints first. Do the endpoints first and do critical numbers second, and you have to find all the y values. Then you just check the y values and you're done. Sure it does. If you got the y values of 3, 1, and 2, the maximum's 3 and the minimum's 1. You check the y values. Yeah.
Endpoints first.
Endpoints first, and then all the critical numbers. Critical numbers where the derivative equals 0 or undefined. You got that written down? You want me to walk over there? Calculate the endpoints, f of a and f of b. Then find all the critical numbers. Yeah, okay, you know what? I'll just let you go for a month and we'll meet up later and see how it's going for you. Moving on. Sketch the graph and find the extreme on the interval. Does anybody know what x minus 1 to the 2/3 power minus 4 equals? I don't either. But I do know that these are my endpoints, right? 0 and 9, so I can put those in. How do I take the derivative of this? 2/3 x minus 1 to the negative 1/3 times 1. Okay? So that's the derivative. Is there any place that's going to make that undefined or equal to 0? Yeah, I would say at 1. You look at factors and they tell you what's going to equal 0. Remember in the last chapter, I said you got to learn to factor these derivatives because you're going to be solving them. Well, set it equals 0. And if at 1, it makes it undefined. That's a critical number. Or for part A, is 1 between 0 and 9? Yes, it is. So there's 3 y values you have to find. 0, 1, and 9. For part B, 1's getting thrown out, isn't it, because of the parenthesis? So 2 is the only one you have to calculate. And in letter C, the endpoints are thrown out, so you only have to calculate the 1. Does that make sense?
Like put in 1 for the f.
Yeah, put in 1 for the f of x and find the y values.
So you're just going out for 1 because it's got parentheses now.
Right. That means 1 can't be an answer. All right, so now we're going to go to the graph. I'm not there yet. Yeah, I just did 0, I did 1, I did 9. Yeah. So which one's my maximum on part A? 0 what? Oh, 9, 0 is my maximum. And my minimum is 1, negative 4. Do you see how it works with the minimum and maximum? I didn't even need a picture for that. I have no idea what the graph looks like, but I know in the entire sketch of this, there's not going to be any y value bigger than 0, and there's not going to be any y value smaller than negative 4. I know that to be true. Nice. This one? Negative 4, negative 3? You can't. I just had it up there, probably copy and pasted. But I don't know if negative 3 is going to be a big one or a little one, do you?
Wait, do we calculate 1?
I don't know, I think we need to go to the graph. Well, yeah, you got 1 from the previous one. I just threw up there as a reference point. Negative 3 is bigger than negative 4, isn't it? Okay, so it's probably going to be a maximum. That's the only point. Maximum, minimum? I don't know. But the graph will show us. Looks like it's going to be a minimum. With the function value negative 7 and 0. So if you take a look at this graph, yeah, there's going to be a cusp, not a cusp, yeah, at 1. At negative 7.
That one's supposed to count at negative 72.
Now I'm going to put an open circle right there, negative 7, 0. I'll put a closed circle at 1, negative 4. And then I'm going to put 2, negative 3. So graph is coming in, spiking, and making an open circle. That's going to be a minimum. All right? There's a parenthesis there. That means it can't be there, so you just put an open circle. That tells you it's going to be a minimum. Okay? So I'll try to go through, I don't know, 5, 6. Okay? Do another round of rapid fire tomorrow. Here's number 6.